Multiple disc clutches. Multiple disc clutches are used to deliver extremely high torque in a relatively small space, while still retaining the ability to engage and disengage at speed and under load. These clutches can be used dry or in an oil bath. Running the clutches in an oil bath also greatly increases the heat dissipation capability. Typical applications are machine tool, industrial and marine gearboxes, automotive transfer cases, agricultural machinery. The key components in a multiple disc clutch are the bearing, coil, rotor, inner discs, separator springs, outer discs, armature, drive cup. Multiple disc clutches operate via electrical actuation but transmit torque mechanically. When voltage current is applied to the clutch coil, the coil becomes an electromagnet and produces lines of flux. Coil voltage is usually 24 or 90 DC, but other voltages are available. This flux is transferred through the small air gap between the field and the rotor. The rotor portion of the clutch becomes magnetized and sets up a magnetic loop which attracts both the friction discs and the armature. The attraction of the armature and discs squeezes the inner splined discs that ride on the rotor against the outer discs, transferring the torque. For an oil bath application, the oil is squeezed from between the friction discs, but a thin film still remains, so the torque is being transferred through an oil shear force. The tangs on the output discs push against a drive cup, which is attached to a pulley, coupling, or gear. Depending upon inertia and speed, the clutch will slip to accelerate the load, typically within 0.2 to 2 seconds. To disengage the clutch, current voltage is removed and the separator wave springs prevent the inner and outer discs from making contact. But there is still a minimal amount of drag present from the separator springs.